Welcome again students in the today's online class. Today's topic is mutual induction. Mutual induction is the process by which changing electric current in one coil induces EMF in the nearby secondary coil. So for this we have a diagram over here in which we have made a primary coil, that is coil 1, which is connected with a battery, a tapping key and a rheostat, and the secondary coil, that is coil 2, connected with a galvanometer. So what happens when we tap this key, the current starts flowing from 0 to maximum value and therefore it generates a magnetic field around it. This changing magnetic field then passes through the secondary coil and induces an EMF inside it. So this phenomena of generation of EMF in the nearby coil due to this first coil is called mutual induction. Mutual means a pair of two. So the EMF induced due to the changing magnetic flux through the secondary coil due to the first coil is called mutual induction. So therefore the magnetic flux is directly proportional to the current, because when the current increases from 0 to maximum value, then the flux changes. So the change of the flux, or you can say that the flux is generated due to the presence of the electric current inside the coil. So flux is directly proportional to current. On removing this proportionality sign, we get a constant, that is M. M is called mutual inductance into I. So this is the formula of flux and M is called mutual inductance. And the unit of mutual inductance is Henry, just like self-inductance. Now this formula can also be represented in terms of EMF, that EMF is equals to d phi upon dt. But if we remember about Lenz law, we have to mention a negative sign over here. Now the formula becomes EMF is equals to, at the place of phi we will substitute M into I, and M is the constant of proportionality, so it remains constant, and the EMF generated because of the change of the current. So we will mention di upon dt. So EMF gets induced because of the change of current. So that's why it is represented di upon dt, that is the change of the current with respect to time. So here are the two formulas, that is in the terms of magnetic flux, this is in the terms of EMF. Now if we move to the derivation about the mutual inductance of a two coaxial coil placed close to each other, then we are having the diagram mutual induction of two coaxial coil. Now we are having two coils over here. Let us suppose the first coil is named as P, second coil is named as S. The primary coil is having current I1, and this current will produces an magnetic field around it, which then passes through the secondary coil and generates an EMF inside it. Now due to this primary coil, let us suppose it produces an EMF, that is phi 2, which passes through the secondary coil. So the EMF in the secondary coil is phi 2, which is due to the current in the primary coil. So we have mentioned phi 2, that is flux in the secondary coil, which is produced due to the flow of current in the primary coil, that is I1. Now according to the formula, phi 2 is equals to mutual inductance into current. So M is being replaced by this proportionality sign. Now according to the flux, we have also assumed that flux is also a magnetic field into area. Now the flux is equals to magnetic field into area into number of turns, because we are having a number of turns of the coils over here. So the flux to the second coil will be due to the magnetic field of the first coil. So therefore it is B1 over here. So phi 2 is the flux of secondary coil due to the magnetic field of the first coil. Now the flux due to the secondary coil will be due to the number of turns of the secondary coil also. So here N2 is here. Now flux हमने यहाँ पे लिखा है कि phi 2 जो है वो secondary coil का है, किसकी वजह से है? First coil की magnetic field की वजह से है. अब फ्लक्स जो सेकेंडरी कॉइल का है वो उसके नंबर ऑफ टर्न्स पे भी डिपेंडेंट है. नाउ then again the magnetic field, now we have to replace this B1, so we are having a formula of magnetic field, that is mu naught Ni, right? So magnetic field, that is for the first coil, that is primary coil B1, the formula will be mu naught, that is permeability of that medium, into number of turns of the primary coil into the current of the primary coil. And we know the formula N, that is number of turns per unit length, that is capital N, it represents number of turns, L represents length of the coil. Now put the value of this B1 in equation second. So we have to put this value B1, because I have already told you that we need to substitute this value of B1. So I'm putting this value of B1 over here, we get this relation. Okay. Now we are going to replace this N by capital N. So we are having this formula over here. So the capital N, small n is being replaced by this capital N upon L. Now this is our third equation. On comparing equation first and equation third, we get this relation. Because left hand sides are same, so on comparing the right hand sides, on comparing we observe that this current I1 gets eliminated with this I1. And this is the final expression for the mutual inductance.